Hello guys, welcome back. In this video, I'd like to explain you NumPy. Why we need to go for NumPy other than normal Python. So why I need to use this NumPy library. Let's say I have a list which contains some values like this. Then, so for let's say I want some of these elements. Like I want to perform some of these elements, or I want to perform some manipulation action on this. So for a 1D array, if you want to perform a manipulation action, then it is easy in case of list if we take. But in case of nd array, that is not one dimensional. If the dimension of the matrix, let's say if you are taking n dimensional matrix, n by n cross, during that time it is better, or it is easy to perform the manipulation by using a numpy array. So you can think like a NumPy as a combination of list plus some memory related actions. So if you are expecting to perform a list, or you can say array based or matrix based operations, during that time this NumPy will take very less time. So can you tell me why this list is taking a very large time compared to NumPy? Why NumPy is taking very less time? So here the reason for the that is in NumPys. For NumPys, memory stores in contiguous format, like a contiguous memory will be allocated for NumPy. And you can see the ground level at the low level it was coded in C language. So that's why NumPy is efficient for data manipulation tasks. For data scientists, this NumPy is highly used. So for data analysis tasks, we consider NumPy. That is actually present in Python itself. We just need to import it in order to use it. So how to import it, sir? You just write a import statement with NumPy as np, so that it was imported. Np represents your NumPy package. Now I want to use this and create an array. So let's say I have a list. Now I want to create an array by using that list. So how to do that? How to create an array, or how to create a NumPy array using a list, sir? For that, in NumPy, there is a method called array. So by using this, you can able to create a NumPy array by using a list. You can see array of this represents NumPy array. Let's assign this to a variable called ARR, and let's ask the type of this ARR. So what is the type of this variable? You can see NumPy nd array. So NumPy array type it is. Let's say I want to check. So whatever the values which are present in this array, that array related data type. You can say values related data type. What is the data type of my NumPy array values? To get this, you just need to write your array name dot dtype. That means the data type. You can see currently it's a 64-bit integer type. Let's say I don't want integer. I want to convert that data type into float. So is there any method that is type conversion or typecasting? So how to do a typecasting with an array? So just write the array name dot as type. So this is the very simple method that you need to use to convert from one type to another type. Then you need to provide, so which type you want to convert to. So np dot, so currently it's an integer type. I want to convert it to float type. You can see float, in float you have multiple options are there. Currently I just want to put to 64-bit type. So I just written this. Now you can see the array will be converted to float type values, but since I do not assign it to anything, arr value will be still integer. If you want to assign the updated value, then just assign it. So currently I don't want, so I'm not assigning anything. Now mm, you have seen how to create a numpy array by using a list and a data type of it and type conversion you have seen. Let's see the dimension. So what is the shape, or you can say I have told this is a one dimensional, right? Yes. So that I want to identify by using some code. If you want to identify the dimension of a array, numpy array, then just type array dot, so ndim. That means what is the dimension of it. You can see it's a 1D array, so that's why it is showing 1. Let's say I want to see the shape of it, like I want to see the number of rows, columns, or you can say how many dimensions I have. In those dimensions, in each dimension, so how many values are there? That I want to see. So how to see that shape? So for that also very simple, array dot shape is the method that you need to use. You can see. So it is only one dimension. That is only rows are there. One row, single row is there, and you can see in that dimension also you can see four. That means four values are there, right? Yes. Let's say I don't want this dimension. I want to convert this to 2 by 2 matrix. Then how to do that? For this, you have seen previously the array is 1D type. Now I want to convert it into 2D. That is array. This array I want to convert it into 2D. You can see this is the array, right? I want to convert it into 2D. How to convert this into 2D? For that you can use dot reshape method. Then in this you need to specify what is the dimension that you are expecting. Let's say I want to convert it into 2 by 2 matrix. You can see it's converted into 2 by 2 matrix. And so after converting, I want to assign it to some array 1. So I assigned it. Now I want to see this array 1 how it's look like. You can see it's look like a 2D array. Let's say I want to find this dimension of this array 1 using ndim method. You can see it's a 2 dimension, so that's why 2 we are getting. For previous it's a 1 dimension, so 1 we are getting. Since it's a 2 dimension, now we are getting 2. And now I want to see the shape of array 1, like how many rows and how many columns are there. So like this, not only to 2 dimension, you can also convert it into 3 dimension as well. That is directly from 1D you can able to convert it into 3D or 4 dimension as well. Let's say I want to reshape this to 2 comma 3. Is it possible? No. Why 2 comma 3 is not possible? Because number of elements are not sufficient. 2 cross 3, how many? Totally 6 elements are required, but how many elements we have? We have just 4 elements, so that's why it is not possible. Let's say I want 1 comma 1 comma 1 comma 1. That means here, so I think the method name I forgot. I have written wrong. Yeah. So now cannot reshape array of size 4 into this. So like this format also it was unable to reshape. The reason is that since the elements must match with the dimension that you are specifying. Let's say if I specify 1 comma 4, you can see only one row but 4 columns you got. Let's say I want 4 columns but only one row. You can see 4 4 rows and 1 column. That is the first row, second row, third row, and fourth row. But only one column is there. So like that, based on rows and columns that you mention, it will be rearranged. So that's how this will be happen. But as of now, you can see array 1. How it will be? It's a 2 by 2 matrix, right? Yes. Now I want to convert this 2 by 2 matrix or n by n cross n array. I want to convert n cross n array to 1D array. So how to get this? 1D numpy array. So remember, if I am specifying it's an array, then it's a numpy array. Since we are working on numpy arrays, so assume whenever I call array, it's as a numpy array. Now let's have n by n cross, that is a 2 by 2 matrix. I want to convert it into 1D array. Then how to do that, sir? Array 1 dot flatten. Here we have two options. One is a flatten method. Here you can see after flattening we got the one dimensional array. Or else you also have one more method, that is reshape. What is that? Reshape. By using this reshape also, just provide -1, so that you can see one dimensional array you got it. So like that you can able to convert from one shape to another shape and flatten as well, 1D array as well. You can able to get 1D array as well from n cross n dimensions. Let's say I have an array and I want sum of elements of that array. Let's take ARR as my array. Now for this array I want sum. I want to print sum. Then just use this, so that, or you can say just use sum of this array, so that you can see 10 you are getting, like 3 plus 2 5 and 4 plus 1 5, 5 plus 5 10. Yeah, so totally 10. So now you got the sum of elements of the array. Now let's see, like adding a row wise expansion, or you can say let's move back to this reshaping only, or you can say dimensions. Now I want to expand. So let's say my array is this. Let's say this is my array. And what is the shape of it? 4 comma. So that's it. Now I want to expand this. I want to put some index before. I want to expand it in a row wise fashion. Like first I don't want 4. I want some other value. After that I want 4. So like that I want to expand it. So how can I able to do that? So for that row wise expansion, you can use np dot expand dimensions of, first we need to specify what is our array. Then we need to specify the axis, that is equals to 0 for row based expansion. So as you can see, and so let me assign it to another array, and let's see the shape of this. So now you can see it's a 1 comma 4. That means it's now becomes a 2D array. Previously it's what? It's a 1D array. But now it's becoming what? 2D array. That means array 1 dot shape you can dimension you can able to see. So it's a 2D array. But for array ARR, if you check with the dimension, like n dimension, what are the number of dimensions? This is one only, but you expanded it in axis is equal to 0. That means row wise. That means for the first entry value it was entered. That means row wise it was added. So if you observe the difference, so it's a list of list, like it's a 1 comma 4. If you see, so before expanding, how it will be, how 1D array will be, you can see it's just a single list, but it's a list of list. So it's expanded in a row format. Now I want to expand in a column format. I don't want row based expansion. Now I'm expecting some column based expansion. Now let's see that. That is here. Now what happens is if we do column based expansion, the expansion will be happened in from second row. So as you can see for array, what I'm doing the same thing. np dot expand dimensions of, so what is our array? ARR. And so what is the axis? So currently it's a 1. Why? It's a column based expansion. So that's why I'm providing axis as 1. So now you can see how the array will look like. Let's store it in ARR2 variable. Now let's print this ARR2 how it will look like. You can see previously it's a row based expansion. Now it's a column based expansion. Now let's say I want to see with, so what is the shape? Array2 dot shape. You can see it's a 4 by 1. Now, so previously it's expanded in a row based. Now it's expanded in column based. You can observe the output, and at the end I want to see like a shape dimension of it. It's a 2D. I can able to observe that. And for code based observation, I have just written this ndim. Now let's see with how to generate different numpy arrays. Let's say I want to generate different dimensions of zeros. For that, just np dot zeros is the method that you need to use, and within the braces you just need to mention the shape. Let's say I just want 1 1 0, so like this. Let's say I want 3 zeros in 1D, so that's it, that's in this way. Let's say I want to generate 2D array with 3 comma 2 as the dimension. So now you can see 3 rows and 2 columns. Let's say I want in the same way 3D array of zeros generation, 3 2 and 3. So in this format I want, you can see, so in this way you can able to generate n cross n cross and so on. So what dimension you want, in that dimension you can able to generate zeros randomly. Sir, can I do the same thing with ones? Can I generate the ones in the same format how I generate zeros? Yes. For that in NumPy we have ones, that is np.ones method is there. There you can specify what is the dimension that you want your ones. Like I want 4 rows and 2 columns related ones, so that's why I generated like this. Sir, can I have another way? Yes. You can also use empty is the method name. There you can provide the shape like 2 comma 4 or 4 comma 2. If you type 4 comma 2, then same like above you can able to generate your ones. Let's say I want to get some identity matrix. So how to generate it, sir? For that identity matrix generation, you just use eye and just mention what dimension you want. Let's say I want to mention 3 dimensional, or you can say 4 dimensional identity matrix. You can see 4 dimensional identity matrix you got. It's a square matrix only. You cannot able to specify like a rectangular, like 4 comma 5. Then you can able to, yeah, you can able to get it as well. Let's provide 3D. So that's also possible. Let's provide with 4D. So you can see cannot generate interrupting some data type issues is there. Okay. So you can able to generate up to 1D, 2D and 3D of these identity matrix by using this EYE. Now let's see with copy method. So how copies vary from normal referencing. Let's say I have an array. that is 1 comma 2 comma 3 comma 4 45 comma 6. Like this I have some array. Now I'm just assigning it to ARR1, array 1. Now in both ARR and in my ARR1 I have the same type of values. Now what I will do is in my ARR1, let's say I am requiring to update the 0th index value to 0. Now you can observe the 0th index got updated. So if you do this type of direct assignment, then what happens is, so whenever you update the array 1, then what happens is in the original array also it will be updated. You can observe that, right? It was updated, right? But previously it was 1, now it was updated. But in case if you take if you take array, or you can say take if you use this copy method, then what happens is actually this array got updated to 0, so that's why I have again running this cell so that ARR will be updated now. You can see, yeah, ARR will be this value. So now if you use this copy method, then what happens is, so just this data will be copied to this array. That's it. So if any modifications happens in this array or in this array, so both are not interlinked. That is, if any modifications happens in one array, does not replicate in another array. But here, if you assign like this, then directly, then so if one update happens in one array, then that will be definitely replicated to another array that you have seen just now. So let's say in middle itself, I want to show you that. Like in ARR2, I want to update. So first, let's print this. Okay, this is how ARR2 will be. I think this was not worked. Yeah, now you can see this what ARR2 will be array 2. And now in this array 2, I want to update the third element to be 4. And now I want to print that array 2. So what is the array 2? The third element will be 4 and the fourth element will be 6. You can see under 45 it just updated to 4. Now let's print with this ARR. So does it updated? No. Why? The reason is you used this copy method, so that's why it just copied the current reference. It does not assigned or referencing to the wh- whole array. So if you assign directly, then it will reference. It will take the reference as the array. So if you use the copy method, it just copy the current reference values of array. So this is what happened if you use this copy method. So that's about this copy method and normal referencing difference. Now, so at the end we'll discuss these three and then we'll wind up this, like slicing, arithmetic operations as well as some built-in methods. We'll observe and then we'll finish the session. So first slicing. So how to do this slicing? So as same like how do you how do you slice a string or a list in a Python? So in the same way you can use this slicing operations in NumPy arrays as well, on top of NumPy arrays as well. For the 0th element you can write 0. Let's say I want a last element. So I want to write -1. Let's say I want the elements from 1 till 4. So 1 till 4 I want. So you can see the middle elements I got. So like that, the slicing you can able to do. 0th element you can able to get, and the last element also you can able to get by using -1. So that's a brief about this slicing. Now let's see with the arithmetic operations. So what do you mean by arithmetic operations? That means addition, subtraction, multiplication, division. So these are the things. Let's see. Let's say I have an array that is so this I have. Now I want to perform some addition with 1, array plus 1. Then what happens? What actually happens internally? So let's see that. So what happened? Cannot concat int to list. So okay, it's not a list. I want to create a numpy array. Okay, now you can observe. So what happens? The array will be considered in the backend, and plus this got added with 1 comma 1 comma 1 comma 1 comma. So totally how many? 5. Yeah. So still we provide only one. We are adding with an array. For each element in the array, it was added internally. The same thing happens with multiplication, subtraction, as well as the division as well. You can observe that, right? It got multiplied. So 2 into 1, that's 2, 2 into 2, 4, 2 into 3, 6, 2 4 is 8, 2 5 is 10. Yeah, so that's happened. Let's do division. So for each and every element, the division got applied. As well as subtraction is pending, right? Yeah, that's also let's do. Yeah, so for each and every element, the subtraction got happened. So in this way, if we do a single operation, you can say by using a single element, if you perform the arithmetic operations with an numpy array, this is how that will be. Let's say you have two arrays. So one array is like this. So np dot array of. So let's take it will be some 2D list. Let's take it as a 2D list like 1 comma 2 and 2 comma 3. So let's take it. Let's see the shape of it. It's a 2 by 2 matrix. So in the similar way, let's take a B, one more matrix with some, let's take some different values. Okay. Now let's also see the shape. So since both are having the same shape, now let's perform with addition a plus b. As you can see, 3 plus 1 4. So each and every element in that particular position got added, and their result will be printed here. You can see, yes. So if I perform the multiplication, you can see 3 cross 1 will be 3, 2 cross 2 will be 4. The same thing happened with multiplication. If we do subtraction, so the same thing happened here for the b. So here the 3 is there and a 1 is there, so 1 minus 3 it's a z minus 2, and here 2 minus 2 0, and here 3 minus 1 it will be what? 2. So addition, subtraction as well as multiplication happened. Let's see with the division. Yeah, division also happened. So this is what we get after performing arithmetic operations between two numpy arrays. And at last, let's implement some built-in methods which are present in numpy array. We have multiple built-in methods, but among them we just use a few. Let's say I want to see how many methods are there. For that, I'm using this dir of this. So what? NumPy. And so let's list, or let me show what are the methods you have. You can see, so a lot more are there. I cannot able to count them. So let's use the length method to count them, like how many methods there are. So 533. So totally those many there, those many built-in methods are there, so you can refer. But among I'll just show you like top level. So I have this array. Now I want the sum, or you can say I want the sum of all the elements of that array. So just like this, I want square root of elements of it. You can see, let's say I want mean of my array, and I want mode. You can say the mode option is also there, mode of that array. I think median option is there. Yeah, I think mean option is there as well as a median option is also there. And along with these, we can able to find standard deviation as well for a numpy array. And for an numpy array, let's say I want to find the minimum value of that array. So this is the way. Let's say I want a max, so that also you can able to get. And let's say I want the location of minimum value. What is that? Location of minimum value. So how to get that location of minimum value? For that, np dot min of that array, so that it will provide you the minimum value of an array location. Let's say I want maximum value location in my numpy array. Location of max value. So that you can able to get using aug max of that array you can provide, so that it can provide you that location. So in the second index, the max value is there. Is it true? 0 1 2. So in the second index 3 is there, that is the max. Yeah, that's true. And randomly you can able to generate some integer by using np.rand random.randint. You can see this option is there. There you can provide like the range. So in between 1 to 100 I want some random integer. So currently it generates a 20. I just copy paste the same command. Now you can observe 30. If I run this again, new, so like this it will generate some random value in between specified range. Let's say I just not sufficient with one value. I want 10 values, 10 random values. You can see just provide the size. I don't sufficient. You can say I am not sufficient with only 1D value, 1D array. I want 2D array. So you can provide that 2D array size, so that you can able to get it as well. Let's say I want dot product of my matrix. I want dot product of my matrix. Let's say I have AB. You can see, okay, let's take this A value, assume this as A, and let's take the B value as well, and this is my B. Now I want to perform the dot product between these two, A comma B. So this simply you can able to get it. And in addition to these, you can able to perform linear algebraic operations like inverse inverse of a matrix. So how to get the inverse of a matrix, sir? np dot linear lin algebra dot inverse inv of this a, so that for a inverse you got, let's say I want transpose, I want, or you can say I want a det. So how to get a matrix det, sir? So np dot linear algebra dot det of that matrix. So that's it, you got the det. And let's say I want to find the eigenvalues after solving this matrix. What are the zeros possible eigenvalues? For that you can use linear algebra dot eig. So to get the eigenvalues of a matrix, you can see these are what? These are the eigenvalues of a matrix A. So this is all about so not only this, so you have multiple built-in functions as you have observed, that is totally 533. So refer based on your requirement. So this is a basic intro about NumPy or NumPy arrays. So this is all about NumPy arrays and how to perform data analysis actions. So in this, what you have learned? You have learned about data type conversion and finding the data type of an NumPy array, as well as finding the shape as well as the dimension of an NumPy array and converting from one dimension to another dimensions you have seen. And you have also seen row based expansion as well as a column based expansion, that is here axis is equals to 1, that's a column based, axis is equals to 0, it's a row based expansion. Then you have also seen generating of NumPy arrays by using zeros, by using ones you have seen, and identity matrix generation you have seen, and copying. So you have copy method as well as the referencing of an NumPy array option is there. So you have seen with the both, you have seen with the both options. Then you have this arithmetic operations, so that you have seen. And so I think it's look like a list. Yeah. So the same will be applicable for NumPy array as well. So you can see I just assigned this array to this array 1 and copy to this array 2. If I see the array 2, then it will be this. Array 2 of 3 I updated. As you can see the updated array, but the original array do not change. Since you updated the array 2, that means copied element, then also the original array won't change. And array 1 also not changed. So in array 1 if you updated, then you can see 0th element you updated. If you observe, the original array also got updated since you just referred the original array. So that's the same functionality in normal list as well as this NumPy arrays as well. So you are seen with the slicing, and you have also observed with arithmetic operations with single digit or single digit and an NumPy array, or else in between two NumPy arrays also you have observed the arithmetic operations, and you have observed the top, or you can say mostly used built-in methods. And you have understood like so how many built-in methods are there totally as well, and how to get one by one, or you can say how to refer those. By using this you can able to refer these. And let's say if you want to see specific method, let's see I want to check up with the first method which is available here. So what is that in the top, what is there? Yeah, so let's take this full, and let me get the help of it, or let me know about it. So you can see, so help of that particular function will provide you about that, as well as it also provides you some examples as well. explains about that method as well as the examples about it. So that's about this NumPy array. I hope you understood this and you got some knowledge about NumPy array from this video. I hope this video is useful. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye, guys.